We are doing multiple choice question of the chapter Force in Motion, and this is part 3. Okay, let's start. Multiple choice question. First set. Among the following, which one is directly proportional to the weight of the body at a given place? Look at these are the options. And another question, which of the following equations is correct? Here we have 4 equations. We have to select correct equation. Next, in which situation does an object become weightless or have negligible weight? These are the options. Okay, let's see. Number 1. Among the following, which one is directly proportional to the weight of the body at a given place? At a given place, we have to focus this. Okay, which one is correct? Look at this. We are talking about directly proportional. What is directly proportional? Weight of the body. Weight of the body depends upon mass of the body and acceleration due to gravity, m and g. For a particular place, g remains same. That's why weight depends upon mass of the object. That's why this is the correct option. Okay, which of the following equations is incorrect? G is inversely proportional to r square. This is correct equation, and g is equal to f r square upon capital M small m. Now if capital M and small m is taken to left hand side and r square is also taken to left hand side, then we'll have f equal to g capital M small m by r square, and this is correct. Like f equal to g m1 m2 by d square. In place of m1 and m2 we have capital M and small m. In place of d we have r. Okay, this equation is also correct. We have to select what? Incorrect. Okay, C. G dash equal to capital G capital M by R plus S whole square. G dash means acceleration due to gravity at certain height, not on the surface. On the surface we'll say small g, but G dash means acceleration due to gravity at certain height, and it is calculated by using this equation, radius plus height. So this is also correct. And last one, look at this, small g equal to capital M small m by r square. This is incorrect because it should be small g equal to capital G capital M by r square, not capital M small m. Okay, that's why number D is correct option. Okay, let's have third. In which situation does an object become weightless or have negligible weight? In which situation? When the body is freely falling, when it is in the space. When a body is freely falling, its weight becomes 0. Yes, we have to see second option also, because in second option also weight becomes 0 when the body is in a space, because weight of a body is the pulling force of the earth acting on that body, or weight of the body is the pulling force of the heavenly body acting on that body. But in the space there is no any pulling force. That's why when a body is in space, at that time also weight of the body becomes 0. When inside a satellite orbiting the earth, if a satellite is orbiting the earth and a body is inside it, then at this time also the body becomes weightless. That's why this option is also correct. That's why A, B, C all are correct. So number D, all of the above is the correct answer. Okay, let's have another set. Look at this, the acceleration due to gravity on the surface of the moon is only 1.6 meter per second square, whereas on earth it is 9.8 meter per second square. Why? Here we have options. Okay, we have to select one. 5. Jupiter's mass is 319 times that of the earth, but acceleration due to gravity on its surface is only about 2.5 times greater than the earth. Why? These are the options. Now another question, what type of motion does a freely falling body exhibit? What type of motion produces in a freely falling body? Okay, let's have question number 4. The acceleration due to gravity on the surface of the moon is only this 1.6. It is very less in comparison with the earth 9.8. What is the reason? Earth's mass is much greater than the moon's mass. Moon's radius is larger than the Earth's radius. This option is wrong. The moon's radius is less than the Earth's radius. That's why B, we can say directly this is wrong. Okay, C, the moon has no atmosphere. Atmosphere doesn't have any relation with acceleration due to gravity. That's why this option number C is also incorrect. None of the above. If A is incorrect, then certainly none of the above. But look at the A. Earth's mass is much greater than the moon's mass. Yes, it is correct. and because of the greater mass, its gravity is greater, and because of the greater gravity, the acceleration due to gravity will also be greater. That's why its acceleration due to gravity is 9.8, but the acceleration due to gravity of the moon is only 1.6 meter per second square because of the less mass. Okay, option A is correct. Now, question number 5. Jupiter's mass is very huge, 319 times greater than Earth. Even though acceleration due to gravity on its surface is only 2.5 times greater than the Earth. What is the reason? Okay, let's go through the option. It also depends on mass of the body. This is so funny to say, because the mass is greater, already told. It also depends upon mass, also means it must be some other matter. It also depends on radius of the Jupiter. It seems to be correct. Let's see another also. It also depends upon distance from the sun. It doesn't make any difference. The distance from the sun doesn't make any difference to acceleration due to gravity on the surface of Jupiter. C is completely incorrect. A is incorrect. D, it is largest planet in the solar system. No, this is not correct. Okay, let's come back to B. It also depends upon radius of the Jupiter. Yes, this is correct. Actual reason behind this can be explained this way. Small g depends upon two major factors: mass of the heavenly body and radius of the heavenly body. And mass of the heavenly body is very huge here, 319 times than that of the Earth. And radius of Jupiter is also very huge than that of the Earth. Because of the increase of radius, acceleration due to gravity decreases, because g is inversely proportional to r square. That's why acceleration due to gravity is not so high, only 2.5 times greater than that of the Earth. Okay, let's have 6. What type of motion does a freely falling body exhibit? Acceleration, retardation. Retardation is completely wrong, because in case of retardation, every second the velocity of the body goes on decreasing, but if a body is falling, its velocity goes on increasing. That's why retardation is completely wrong. Uniform acceleration and uniform velocity. Uniform velocity we cannot say, because every second velocity is increasing. That's why among acceleration and uniform acceleration, which one is correct? Uniform acceleration is correct, because every second its velocity goes on increasing by 9.8 meter per second. So it has uniform acceleration. Okay, let's have another set. Here we have the question. In the given diagram, capital M and small m represents the mass of the Earth and mass of the body near the Earth's surface respectively. If the distance between them is d, which of the following statement is correct? Here we have statements. What is the gravitational force between two 1 kg masses separated by 2 meter distance? These are the options. Okay, now another question. Which of the following forces is produced only when objects come in contact? When object comes in contact, which force exists between them? Okay. Now let's have 7. In the given diagram, capital M or mass, small m, a mass of a body lying on its surface or near to its surface, and d is the distance between them. Which of the following statement is correct? The gravitational force exerted by capital M, mass of Earth, on small m, mass of the body, is greater, because capital M has a larger mass. This is completely wrong idea. The force of attraction of Earth acting on this body is equal to force of attraction of the body acting on the Earth. That's why this option number A is incorrect. Number B, the gravitational force between them is proportional to the sum of their masses. This is also not correct, because the gravitational force between them is proportional to the product of their masses. That's why A and B both are incorrect. The force exerted by M, it means the force exerted by the Earth's mass on small m, that is mass of the body, and the force exerted by the mass of the body on the Earth's mass is equal. Yes. With what force Earth attracts this body towards its center, with the same force the body also attracts the Earth towards its center. This is a mutual force and equal in magnitude, but x in the opposite direction. That's why this option number C seems to be correct. All of the above statement are incorrect. No, we have to go through option number C. Okay, what is the gravitational force between two 1 kg masses separated by 2 meter distance? When two 1 kilogram masses are separated by 1 meter distance, then gravitational force between them will be 6.67 into 10 power minus 11 Newton, we know. But if they are separated by 2 meter distance, then if distance is doubled, gravitational force between them becomes quadrant, 4 times less. That's why option number C is correct. 6.67 into 10 to the power minus 11 Newton divided by 4. Okay, now 9. Which of the following forces is produced only when objects come in contact? When two objects comes in contact, then certainly friction acts between those two objects. What about gravitational force? Gravitational force acts from distance. Gravitational pull. Gravitational pull means the gravity of the heavenly body that also acts through the distance. Magnetic force also acts through the distance. But friction comes in action only when they come in contact. That's why this option is correct. Okay, let's have another set. How much distance does a freely falling body cover in 1 second? These are the options. Okay, another. Which of the following equations can be used to calculate acceleration due to gravity? These are the equations. When an object falls from a great height, which type of motion produces on it? We have 4 different options. Okay, now let's have question number 10. How much distance does a freely falling object cover in 1 second? You may be confused with this 9.8 meter. No, this is incorrect. The correct answer is 4.9 meter. But why? Do you know this equation? This is one of the equation of motion, S equal to U plus V by 2 into T. If we apply this equation, you can understand very easily. If a body is dropped from certain height, then initial velocity U is 0. V, after 1 second, its velocity becomes 9.8 meter per second. We know about this because it's at the end of 1 second, its velocity is 9.8 meter per second. So U plus V becomes 9.8 and divided by 2 becomes 4.9 and multiplied by time in 1 second. That's why 4.9 is the correct answer. Okay, which of the following equations can be used to calculate acceleration due to gravity? This cannot be used in the calculation because there is no equal to sign. Here small g is missing, acceleration due to gravity is missing. That's why this cannot be used directly. A and B cannot be used. And this C, small g, that is acceleration due to gravity, is equal to capital M by R square. This equation is incorrect because it should be capital G capital M upon R square. And number D, small g equal to capital G capital M by R square. Yes, this is used to calculate acceleration due to gravity on the surface of any heavenly body. Okay, now this is correct answer. When an object falls from a great height, what type of motion produces on it? And here initial and final motion is given. Initially the body comes in the action of gravity and acceleration due to gravity produces first. That's why acceleration due to gravity produces the uniform acceleration on the body. So at first it has uniform acceleration, but when its velocity goes on increasing and increasing because of uniform acceleration, a condition comes when the gravity force is neutralized by the air resistance. From that point, the body starts to fall with uniform velocity. That's why we have to source the option which contains uniform acceleration and uniform velocity. Okay, initial uniform acceleration, final uniform velocity. Now it is present in first option. Initial uniform velocity, this is wrong. Initially non-uniform acceleration, this is also incorrect. Initially uniform acceleration, yes, and finally non-uniform, this is incorrect. That's why option number A is correct. Okay, let's have last question. We have a statement and 2 regions are given, and which option is correct? We have to select one of the option. Okay, statement: the acceleration due to gravity of all the freely falling body is the same. Yes, freely falling body means not in the air. Free fall is possible only in vacuum, whether it is feather or a stone or a huge mass. All of them falls with the same rate. That's why acceleration due to gravity of all the freely falling body is same. Statement is correct. Reason A, it does not depend on radius of the earth. No, it depends on the radius of the earth. If a body is dropped at the pole, its acceleration will be more. If the same is dropped at equator, the acceleration due to gravity will be less. That's why reason A is incorrect. Depends on radius of the earth but does not depend is told. Okay, reason B, it does not depend on the mass of the object. Yes, it doesn't depend upon mass of the object. That's why statement and reason B are correct. Only the statement is correct? No. Only the reason are correct? No. The statement and reason A are correct? No. The statement and reason B are correct? Yes, this is the correct option. Okay, today I want to finish this force and motion multiple choice question. In next class, I am planning to give you question answer, not multiple choice, of the same force and motion. Okay, now I want to stop.